Hello, everyone. Welcome back. We've been talking recursion. Yesterday, I had you submit your exam prep to Canvas. Canvas was having issues. Womp womp. So the most likely outcome here is you all get a 100. Yay! But we're going to spend today, because it was requested, kind of reviewing this, talking about exam prep and how it's going. I don't. There's chat. Hello. What happened? Canvas just seemed to be bogged down, like probably just a lot of traffic, to be honest. But you know, if Canvas is having issues, then they're all having issues. So we're going to go through these now. Bear in mind, it's been a year since I've looked at this, so we're looking at it live. If I do something that seems really stupid, it's because I am, but we'll figure it out. So question one: which of the following statements about recursion is true? Every recursive algorithm can be written iteratively. Yes. Recursion is an alternative to iteration. Tail recursion occurs when the recursive call is the last statement in the recursive method. Yep. The base case represents the simplest entity in the problem set. These are all true. This looks like a question I wrote to be fair. Our answer here was echo. Which of the following, when used as the body of the method's sum, I hope everything's here, will enable the method to compute 1 plus 2 plus n correctly for any value where n is greater than 0. So some precondition stuff here that tells that n is a positive integer. Positive as in that it can't be 0. And then we're going to return 1 plus all the way to n. Okay? Interesting. We're going to take in an integer n. Ultimately, we need to spit back out an integer. Well, this one's not going to work because it doesn't have a base case. So we see that our answer here is bravo, right? If n is 1, we just return 1. Otherwise, okay, that looks pretty good. What is wrong with choice 3? Go ahead, hit me up. What is wrong with choice 3 here? Can we see that? I need to zoom in maybe. Problem here. Yeah, some n is going to give us a stack overflow, infinite recursion. So while this recursive call will trend towards the base case, right? Keep in mind we've got a positive number and we're eventually going to hit 1, right? This is our base case. If n doesn't change here, it's going to be infinite. It'll work if n is exactly 1, but that's it. All right, so 2 only. 3 will cause infinite recursion, a stack overflow. Answer there was bravo. Number 3, we have string recur, which takes in a string s, and we want to know if the length of s is less than 15. We're going to print out s as it is, and then we see a recursive call. Keep in mind that we have a void return type, so this doesn't actually have to return anything. Still is a recursive method. We're going to take s and add an asterisk. So which of the following would cause it to terminate without error? Only when the length of the input string is less than 15. If it's less than 15, then we'll just hit this. Hello. I don't know what I'm talking about here. Refer to the method of string recur. When will the method terminate without error? If our string is too short, right, it just stops. If our string is like greater than 15, well, we're actually going to keep making it longer. And so this goes infinitely, correct? Is that less than or equal to? I don't know if that matters. For all inputs, it will keep calling the method infinitely. Right, because this is not a return statement. This is just going to keep printing the string as it is. I mean, it's obvious. My bad. This one is slightly different. If our string length is less than 15, we print off the string as it is, and then it calls itself, again making the string longer. When will it terminate without error? If our string length is less than 15, then we're actually going to hit this and continue to make it longer. However, if it is greater than or equal to 15, we just stop, right? But the thing is, this makes it longer, so it will eventually stop. I don't like these questions, I'm not going to lie. I would prefer to do something like this, where we can just trace it. This seems a little bit more in line with what I would expect on some type of exam. If our input is exactly 1, we return 2. Otherwise, we hit this recursive call. What does result 5 return? Boom, let's do this. I can handle these bad boys. So we start off with result 5. We're going to ask, is n equal to 1? It is not. So we hit this else. We're going to do 2 times result of 4. We're going to ask, is n equal to 1? It is not. So we're going to hit the else, where we do 2 times result of 3. Is n equal to 1? Nope. 2 times result of 2. Is n equal to 1? Nope. 2 times result of 1. Is n equal to 1? Yes. We're going to return 2 in that case. So I can actually solve this recursive call. This is the height of my call stack. We can start collapsing. I'm going to replace that with a 2, which means that I know what R2 is. It is 2 times 2, or simply put, 4. I know what R3 is. 2 times 4 gives me an 8. And what R4 is, 2 times 8, 16. Lastly, R5, we finally can solve it. It's going to be 32. Question 5 and 6, same method, right? If n is greater than 0, how many times will a result be called to evaluate result n, including the initial call? Oh, where's my undo? Oh, I wish I would have left all that. Womp womp. Why don't we do like a shorter one, right? Like if R is 3, maybe that's enough to give me insight to how many times it ends up getting called. We would ask, is this equal to 1? Nope. We do 2 times R of 2. We would ask, is n equal to 1? Nope. We'll hit this else, but we'll return 2 times R of 1. Okay. This time, R of 1 is equal to 1, so we return 2. Here's the height of my call stack, and I want to know how many times did we call result? Well, including the original. There we go. Exactly n. So whatever n, the value of n is how many times result ends up getting called. Sweet. These questions I like. Refer to the method mystery. We're going to take in 3 parameters, n, a, and d. If n is a 1, we return a, duh. Otherwise, we're going to return d plus mystery. These are all duh things. Okay, let's get this going. I'm going to call mystery passing in 3, 2, and 6. First thing I'm going to do is ask, is n equal to 1? Well, one thing to maybe help me here is, let's label these. N, A, and D. Right? Is n equal to 1? No. So we're going to hit this else. So we're going to return D, which is 6, plus mystery, n minus 1. And then A and D stay the same. Right? Okay. Let's step inside of this call. We're going to ask, is n equal to 1? It is not. So we're going to return D, which is still a 6, plus mystery, n minus 1, and then A and D are staying the same. Okay, let's step inside this call where we're going to ask, is n equal to 1? Ooh, it is. And so we return A, which is 2. So this call is going to spit back out A, which is just simply put 2. So I can actually solve that one. I'm going to replace it with a 2. I can solve this one. I'm going to replace it with 8. And lastly, I can solve this one. It's 14. Ta-da! Refer to the method f. Sweet method name. We have k and n coming in. If they are equal, we return k. Otherwise, if n is greater, we do this. Otherwise, we do this. Lots of F's in chat. So, lots of F's on this notepad. Our initial call is F6, 8. We'll step inside. We're going to ask, are they equal? No. So we hit the else, and we're going to ask, is n greater than k? Again, we got these awesome variable names here. This one's k, this one's n. Is n greater than k? It is. So I'm going to hit this return statement. We're going to return k just as it is. I'll almost type the letter k. And then n minus k, or 8 minus 6. That is 2. Let's step inside of this call. We're going to ask, is n equal to k? Is n equal to k? It is not. We'll hit this else. Is n greater than k? It is not, so we'll hit this else, where we put a return statement onto the stack. That is f k minus n. K is 6 minus n minus 2. That'll give us 4. Comma n. Let's step inside this call. Are they equal? Nope. We'll hit the else. Is n greater than k? Nope. So we hit this else. We're going to return f k, which is 4, minus n, which is 2, comma n. Let's step inside that call. Are they equal? Yes, we return k. So there's no math here. This is going to return a 2, which means that I know what this is. It's a 2. And I know what this is. It's a 2. And I know what this is. It's 2. All the way up. Imagine not copying and pasting into IntelliJ. You mean solving them the way they were meant to be solved? Good luck copying and pasting IntelliJ on your test. Dab, 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 dab. All right. What does method recur do? And this one we're taking in an integer array, interesting, along with some type of integer. I know we got questions about this one, because I got questions every year about this one. And we're rocking a sweet 73% on this. Okay, what I recommend is, since they don't give us numbers, is we plug in some numbers for x. So, of note, x is an array of n integers. So whatever value we pick for n, we'll say something like 4, that is the length of x. N is a positive integer. Okay, so they don't say anything about the numbers that are inside here. Only that we'll have, however many of them. In this case, 4. So I recommend, let's make an array with some numbers. Give me some numbers in chat. All right, that's a good spread. So we are saying that n is 4, and our array is going to be this. Now, let's call the method. We're going to call recur, passing in x, as it is, and n, which is 4. Let's step inside that. First thing that happens is t gets created. Okay, there's nothing on t. If n is equal to 1, n is currently 4, we would return this. So we're going to hit our else. where we actually give a value to t, it is going to be recur x as it is in minus 1. Okay, well, I'm actually going to immediately step inside here, and I have code that's waiting to be executed. Maybe something I am interested in doing is actually leaving some type of marker to let me know that this method actually needs to finish it, right? This rx comma 4, it needs to finish. But we're putting this onto the stack, and I'm immediately going to step inside this and solve it. So let's step inside that call. We're going to ask, is n equal to 1? It is not. So I hit the else. Notice there is a t that gets created, and we're actually going to give it a value here, which is recur x in minus 1. I'm going to leave a marker there, let me know that I need to come back to this method, right? This rx comma 3 has some stuff that needs to finish. I'm going to step inside this call, rx comma 2. Right? T gets created. We're then going to ask, is n equal to 1? It is not. So we're going to give a value to t, which is going to be recur x in minus 1. Okay, and I got some code that's waiting to be executed. But we're going to step inside and actually evaluate this. We're going to ask, is n equal to 1? It is. So we're going to return x at 0. Well, x at 0 is 96. So I actually know the value here for this. I'm going to insert that value, and now we're here able to finish out this code. I'm inside of this method call. Okay, so we're going to ask, is x at n minus 1? Inside of this method call, n is 2. So n minus 1 is 1. We're looking at this number. We want to know, is 4 greater than 96? It is not. So we hit this else, which is going to spit back out t. What that means is this rx comma 2, I know the value. It's 96. We're going to hop back into this method here. Right? We just figured out what t is. I need to solve this if statement. We're going to ask x at n minus 1. Inside of this method call, n is 3. So n minus 1 is 2. We're looking at x at index 2, which is 24. I'm going to ask, is 24 greater than t? It is not, so we hit this else, where we're going to return t. Okay. I probably should have looked at our solution down here and realized that I don't necessarily want to put the largest element here. Anyway, I'm going to step back into this call because it's ready to be finished. Inside of that call, n is 4. We're at this if statement. We're going to ask x at n minus 1. So x at 3, that's this 5. Is 5 greater than 96? It is not. So we hit this else. We're going to return t, which is simply put 96. After all of that, we ended up returning 96, which is the largest value in x. This is a nasty method, but that's how we got there. Which best describes the print string method below and what it does. So another one we were trying to figure out what does the method actually do. Similar to the last one, I recommend plugging in some stuff. Why don't you give me a string? We see that our answer here is in reverse order. If you give me race car, I'm just going to die in there. Die in here a little bit on the inside. Thank you. Thank you for that one. Yes. Here comes a list of palindromes in chat. Appreciate it. You're all great. Why don't we do something else? Let's just do hello. So let's call print string. I'm going to abbreviate that with just a P. We could do like PS maybe. P. And let's pass in hello. And I'll put it in quotes to show that it's a string. We're going to ask, is the length of our string greater than 0? It is. So we're going to call print string. Okay. Passing in a substring of hello beginning at index 1, going through the rest of the string. So we'll pass in hello. Right? Of note, there's an SOP here that needs to be printed. So we could leave that as a marker indicating that this method still has stuff that needs to be done. Okay? The indenting here is actually how I'm showing what belongs to what. Right? These two actually belong to this. If I'm going to step inside of this method call, we're going to ask, is the string length greater than 0? It is. There is a call to print string where we're going to pass in low. There is an SOP that needs to be executed, but we got to come back to that. Okay, I'm going to step inside this call where we ask, is our string length greater than 0? It is. So we're going to put a call into the stack, print string, passing in low. There's an SOP that needs to be executed. We'll come back to that. Let's step inside this call. Is our string length greater than 0? It is. So we'll put a call to print string onto the stack. There's an SOP that needs to be executed. Is our string length greater than 0? It is. So we're going to call print string, getting rid of the very first character. And we'll put that onto the stack. We'll step inside this call and we'll say, is our string length greater than 0? It is not. So nothing happens here. There's no return statement. There's just nothing that happens. This is actually solved. Right? So like I can just delete it if I want to. Now I'm ready to hit this bit of code. It's an SOP. It's an SOP for this method call. This is ready to be executed. Inside of that method call, S is O. So when I hit the SOP, what we're going to print off is a substring of S from 0, 1. Well, there's only one character there. It's O. O gets printed. Right? Maybe we should do like a print down here to show where that gets printed. Okay, so I actually just finished out this method call. It ultimately printed off an O. I need to finish out this little bit of code. Okay, that belongs to this method. Inside of that method, the value of S is LO. So when I do a system.out.println on a substring of S from 0, 1, well, that's going to give me just the L here. So we're going to print off L. Here's our little console. Okay. I just finished that bad boy. We're back in this method call. I'm hitting this part where we need to print off. In that method call, S is LLO. So when I hit this SOP, what we're going to print is the first character, which is just simply an L. And then that bad boy's finished. We're inside this method call. I've got some code here. It's an SOP. Inside that method call, S is LO. So whenever I try to print, we're getting the character from 0, 1, or simply put this E. So we're going to print that off. That bad boy's finished. We're finally here. Inside of this method call, our original string, it's hello. I'm trying to execute this code. It's an SOP, where we're going to print off the first character, which is an H. And then that one's finished. Is that it? Was that 10 questions? I don't even know. Final thoughts and questions. This is all. Oh, we had. I left you off with oh gosh, what is that called? A CodingBat that we could solve. Why don't we do that and I'll give you a new one. What did I give you? Count 11. Given a string, compute recursively, no loops, a number of 11 substrings in the string. The 11 substrings should not overlap. So whenever we consider them, we need to get rid of all of them. that right? Yeah. All right, so here we see we got 11 there and 11 there, which is a total of 2. 11, 11, 11, that gives us 3. And this is what they're talking about with the overlap, right? This only has 11 one time. And the way they end up calculating that is that once we see 2 back-to-back ones, we're going to get rid of both of them. If we were to only shave off one and then keep going, we would easily detect another 11. So, as always, I am considering a string, and it's going to get shorter and shorter and shorter. So once our length is equal to 0, I'm going to stop. This will be on YouTube, yes, as always. In this case, we return 0. I've run out of characters. There's no way there could be an 11 if the current character, that is the one at the very beginning, is equal to the very next one. Sorry. If this character is equal to exactly a 1, and the one next to it is equal to a 1, then I have found 1, 1 that's adjacent. What I want to do is count it, so we're going to return 1. Notice that's not in quotes. But we're going to keep our count going and making our string longer. Now, the key here is not shaving off one character. The key here is doing what we naturally would think, which is I've considered 2 characters. I want to get rid of both of them. So I'm going to pass in str, but it is a substring beginning at index 2. So I'm going to shave off the first 2 characters in the subsequent recursive call. If I'm still here, what it means is there's characters, but the first 2 characters, they weren't 1, 1. So we're going to put a recursive call onto the stack, but in this case, I only want to shave off 1 character, because it's possible that just the first character is not a 1, but maybe the next one is, and then the one after that is. So we're going to do something like this, and I'm going to get an index out of bounds, and we'll talk about why. Oh, this is pretty beautiful. Here, we're getting an index out of bounds. Why? Well, here, we're going to ask, is our string length equal to 0? It is not. We're then going to ask, is the character at index 0 a 1? Sure is. Is the character at index 1 a 1? Oh, it is. Well, we're going to count it, and then we're going to call it getting rid of these first 2 characters, which means I have a string with exactly 1 in the subsequent call. We'll step inside that call and ask, is our string length 0? It's not. Is the character at 0 1? It is. Is the one after it a 1? Well, there isn't one after it. So our index out of bounds is coming from our base case, right? If we have a string with only 1 character in it, there's no way we're going to meet our condition of having a 1, 1 substring. So our base case is simply if our string length is less than or equal to 1, well, we could stop there because there's no way that we could have back-to-back 1s. Here I use char apt. Another approach is we could use substring, right? str dot substring from 0, 2. I'm going to get a 2-character substring and ask, is that exactly 1, 1? So there is another approach if you were to use strings instead of chars. The last thing I would consider, which I'm not going to do because we've done it a bunch, but is we have duplicate code here and here. You could, oh, sorry, it's not duplicate. We got a 2 and a 1. I lied. Our solution is pristine. I want you to do the next one. If you have a solution that you're proud of, shoot it to me in Discord. But we're going to wrap it up there, guys. I won't see you tomorrow because it's Wednesday. Let's chill.